Hi everyone, welcome to another video. We're talking today about dividing polynomials. Now this is probably the hardest operation we're going to do with polynomials at this stage, and to do it we need to recall something we've actually been doing for a while, and that is the idea of long division. Now for a lot of you this is probably the first time you have seen or done long division since way back in school. So we're just going to do a quick little recap of the process of long division with this first example that I've got here, divide 405 by 7, and we're going to apply the patterns and what we've learned. I'm going to go through this a bit quicker because it's a recap of something I've talked about at length in other videos. But once we get a hang of that, we're going to apply this idea to the polynomial division in the later examples. So I've got here divide 405 by 7. Now typically when we do this we say, well, okay, how much does 7 go into our first number? Now we can see it doesn't. 7 goes into 4 0 times. So what we're going to do now, we're going to see how many times 7 goes into 40. Now when we divide 40 by 7, it goes 5 times with a remainder. Now to figure out that remainder, first, if we remember before from long division, we can multiply this number here by this one. That gives us 35. So that tells us that the closest whole number to 40 that 7 goes into is going to be 35. Now from here, we basically subtract that one from here to find what the remainder is. That gives us a remainder of 5. And this number down the end gets brought down. So we're trying to find out how many times 7 goes into 55. Now the closest number to 55 that 7 goes into is 49. And it goes into there 7 times. And once again we multiply this by this to get 49, that closest number to 55 that 7 goes into. Now once we get here, we just subtract them to find our remainder. So that gives us 6 here. Now this guy over here is what we call our remainder, the number we have remaining. Now if we think about this, that tells us that in essence we can divide 405 by 7, and we can also write 405 as a product of these two numbers, 7 and 57. So we can write 405 as 7 times 57 plus my remainder of 6. The reason I'm talking about this bit here is because in the questions that we're going to do, we're going to talk about rewriting our polynomial after we've divided it. So in essence, applying this to polynomials, when we divide something through, so I'll give you an example here, we're going to talk about our dividend, the number getting divided. So say we did, I don't know, x cubed minus x squared plus x minus 1. If this was our dividend, the number getting divided, once we divide it through, we're going to get a divisor. Now, this is not a proper example. Sorry, dividend has a D in it. This is just any random example, but just so you can see the form in which we write this, we have our divisor here, we have our quotient, the answer, x squared minus 3x plus 7, our quotient, plus some remainder. In this case, we minus our remainder. This is our remainder over here. So when we do these divisions, we're going to express these things in the form we have over here. Now, what you'll find with your textbooks is when we go into a question like this, divide p of x equals x cubed plus x squared, 2x squared, sorry, minus x plus 3 by x minus 2, we want to write our answer in the form of p of x, our polynomial expression over here, equals to x minus 2, we have here divisor, times q of x, which is the quotient, the answer we're going to get when we divide this, plus r, where r is our remainder. Okay, so let's jump straight into here. We're going to recap the process we did in this previous example and apply it to polynomials. So in doing this, I'm also going to put this little box on the right hand side just for some extra working out. But what we're doing here, we're taking our divisor, x minus 2, and we're dividing the expression x cubed plus 2x squared minus x plus 3. Okay, so let's have a go at this now. So the process ends up being quite similar. Now we want to consider the fact that there is an x here, here, and here. So a lot of the dividing initially we're going to be doing is going to be to do with these x's, which the x is a common factor in all of these terms. So for this first one, dividing x cubed by x minus 2, we notice the x goes into it, x squared times. We can double check that because if I did x cubed divided by x, it goes into it x squared times. So our first term is going to be x squared. And now, to find out the bit that goes underneath here, we want to, like we did with our previous example, we want to multiply this guy up here with our divisor. So I'm going to do that on the right hand side. So I've got x squared times x minus 2. And here we have a number outside the brackets. So we want to expand these brackets, and that's going to give us this thing over here. So the remainder bit we get over here is x cubed minus 2x squared. And we want to basically find this remainder. So we're going to subtract here. If we remember, these two are exactly the same. And with long division, these should always cancel out. If they don't, we're doing something wrong. And here we've got to be careful. 2x squared minus 2x squared is going to give us 4x squared. So we're going to add those two. So this gives us 4x squared. And we're going to bring this guy down here, minus x. Okay, so since we're working with the remainder now, we want to take our next term, which is 4x squared. We want to find out how many times x goes into that. So if we were to, I'll go back on this right-hand side, if we were to take 4x squared and divide it by x, that would give us 4x. Okay, so we do that division. That's going to give us positive 4x. And from here, now we can do that same process again. So we want to take this 4x, multiply it by x minus 2 to give us the remainder. So if I do that on the right hand side again, this is why I've included a lot of little working out space on the right. This way we can sort of check every step as we go. So if we have 4x times x minus 2, still the x was the only thing that could go into the 4x squared. So we're going to get here, when we expand this, 4x squared, then 4x times negative 2 gives you negative 8x. So that will give us my next line. So I have 4x squared. Once again, it's the exact same number. It should always do this. That's how we know we're doing it right. And we have minus 8x here. So these two are going to cancel out once again. And here we have minus x minus 8x. So this is like saying negative x plus 8x. That's going to give me a positive 7x. And now we are looking at our very last term, plus 3. And we are just systematically working through this like we've been doing with long division in the past. Now, finally, we're trying to figure out how many times does x minus 2 go into 7x plus 3. We have to look at the common factor, which is the x here. So, if we go back on this right-hand side here, we're going to divide 7x by x. That's just going to give me 7. And now I want to multiply my 7 by my divisor, x minus 2. Let's see what that gives us. That's going to give us 7x, and then 7 times negative 2 gives us negative 14. So that's going to be my last thing down here. I have 7x minus 14. These two are subtracting to find, finally at the very end now here, our remainder. So that's going to cancel out with that. And I have 3 minus 14. That's like saying 3 plus 14. That gives me 17 as my remainder. Okay, so now we've got our remainder. We found our divisor here that I've got highlighted, x minus 2. And we've got, whoops, the 7 disappeared here. We've got our quotient here. So now we can write it in this form that we talked about before. So we can say by breaking this up that we can write, therefore, x cubed plus 2x squared minus x plus 3. We can write this as the divisor, which was x minus 2 in this case, times the quotient, x squared plus 4x plus 7, plus my remainder of 17. Okay, we're going to do one more example to wrap this up. Here we want to divide p of x equals 2. We have here 2x cubed minus x squared plus 3x minus 1. I want to divide that by x plus 3. So we have a new dividend, we have a new divisor of x plus 3. So I'm going to set this up again. I've got x plus 3, I've got 2x cubed minus x squared plus 3x minus 1. And I'm going to once again include my working out space over here. And let's begin. So I'm going to go through this a little bit quicker. So we can see here that, once again, the x is a common factor here, here, and here. So when we divide these things through, we are going to be seeing how many times x goes into each of these. So the first one, x goes into 2x cubed, 2x squared times. And I'm going to multiply these two to get my next line and figure out the remainder. So 2x squared times x gives me 2x cubed, as we'd expect. 2x squared times positive 3 gives me positive 6x squared. Okay, so I want to subtract these through. These two guys get cancelled out. That's a straight subtraction of a number from itself. That's going to give us 0. And minus x squared minus x squared minus 6x squared gives you negative 7x squared. Okay, and this number comes down. Now we want to see how many times x goes into negative 7x squared. That goes into it negative 7x times. Okay, multiplying these through, negative 7x, we multiply that by this to get our next line down. And once again, we're expecting our first one to be negative 7x squared, which it is, because this has to cancel out with the guy up here. This is just a good way for us to sort of check that what we're doing is sort of working out. And we got a minus here. And negative 7x times positive 3 gives us negative 21x. Okay, sweet. Now, here we have a double negative. So we have negative 7x squared minus 7x squared. That's like saying negative 7x squared plus 7x squared. That is going to give us 0 again. And I have positive 3x minus 21x. That's the same as plussing. So I'm going to get 24x over here. And finally, I have the negative 1 here. We're almost there. We want to see how many times the x goes into 24x. It goes into it 24 times. So we have positive 24 times. And then finally multiplying this guy by my divisor. That's going to give me 24x. And 24 times 3, that's going to be 72. So positive 72. Okay, now we're almost there. Finally, we subtract these off, gives us 0. And my remainder is going to be minus 1 minus 72. That's negative 73 as our remainder. Okay, so now that we've done that, we have our remainder at the bottom, we have our divisor, and we have our quotient. So we can express our polynomial p of x in this new type of form. And we're going to see later why this form is important. So finally we can say, therefore, 2x cubed minus x squared plus 3x minus 1 equals to my divisor, x plus 3, times my quotient, 2x squared minus 7x plus 24, plus my remainder, which is plus minus 73, which I can just write as minus 73. So this is how we can use the same processes of long division from way up when we first saw it and write our polynomials in a different way by finding a quotient as well as determining the remainder. Thanks so much for watching, and I'll see you in the next video.